Hi guys, how are you doing? I hope I find you well. So, welcome to our histology lecture. Today we're gonna focus on connective tissue. So, what is a connective tissue? It's a specialized tissue that provides structural, mechanical, and nutritional support, right? And don't originate from the mesenchyme, that will mainly come from the mesoderm, but it can also come from the ectoderm. What are the functions of the connective tissue? So it has various functions, and one of the most important function is for structural support, right? For tissues, organs, as well as organ systems, e.g. bone and cartilages, right? They provide that structural support. And then you're going to understand that the connective tissue, it can act as a tissue surrounding organs or act as tissue which will connect organs together, right? So you can see, you remember that you have your fascia. It's a part of dense irregular connective tissue. You have your tendons, aponeurosis, your ligaments. These are all dense irregular connective tissue, right? And then it also forms a medium of actions of nutrients, gases, and metabolites between cells and the blood. Remember, the connective tissue is vascular, different from an avascular epithelium, right? So connective tissue can also provide defense and protection, as well as it is important for tissue repair and inflammatory response. Okay, if it is adipose tissue, it is responsible for storing energy in the body. So connective tissue is the most diverse and abundant tissue in the body, and it originates from the mesenchyme that will be derived from the mesoderm. Most of it will derive from the mesoderm, but can also be derived from the ectoderm. It has varying degrees of vascularity, so it is vascular, vascular, and it comprises of non-living extracellular matrix that will be consisting of ground substance and fibers. Right. It also has cells. They are not abundant. So your connective tissue, the most prominent difference between connective tissue and epithelia is that epithelia has more cells than extracellular matrix, while connective tissue has more extracellular matrix than cells. Understand, right? And these cells, they are sparsely arranged, right? They are not connected to junctional complexes as the epithelial cells. So composition is gonna you're going to have cells, which is the living component, and extracellular matrix, which would be the non-living component, making up your connective tissue. Let's start with cells. So cells, they are further those that it takes a longer time in the connective tissue, and transient, those that it takes a shorter time in the connective tissue. So we have four cells that are cells or permanent residents, right? You're going to have your fibroblasts, adipose cells, tissue macrophage, mast cells, right? We are going to talk about each and every one of them in the following slides. As for your transient cells, you're going to have your lymphocytes, your T lymphocytes, your B lymphocytes, which will mature to plasma cells, and you're going to have leukocytes. And your leukocytes are going to be made up of the neutrophil, basophil, and eosinophils, right? And most of these cells, they will be derived from the hematopoietic stem cell in the marrow. Right, so this is just a picture showing, uh, um, this is for the histological slide for the connective tissue. You can see these fibers, right? right? Even if you come here, you can appreciate all these fibers. So these are your collagen fibers. These brownish, these are your reticular fibers, and these are your elastic fibers. And remember, your connective tissue is going to be muscular, and you can see blood vessels. This blood vessel, this is more likely to be a vein, this is more likely to be an artery or whatever. Also going to have your adipocytes, that will be your fat cells, right? And one of the most important cells is going to be the mesenchymal cells. You see these mesenchymal cells. These will be undifferentiated, and if stimulated during wound healing, they can transform themselves to be fibroblasts. Let's start with fibroblasts. These are the most common cells in the connective tissue, right? So they synthesize and secrete component of the extracellular matrix. Extracellular matrix is going to be made of proteins, fibers, protein fibers, ground substance, as well as fluid, right? So the fibroblasts, they can be in active state or activated state, right? If they are active, they are called fibroblasts. If they are inactive, which we call the quiescent stage, they are going to be fibrocytes, right? So their main function, they secrete collagen fibers and grass substance. Also synthesize growth factors, right? Because they are also associated with the wound healing, is it? So if these cells are entered the quiescent stage, they really undergo mitosis. So they really undergo mitosis, very important, right? They also play an important role in wound healing, like I have said, and they are activated. So if they are inactivated, once they sense that the tissue injury, they become activated, and then they proliferate, increase in size, and then what they form what you call scar tissue. Right. So you can see from these two histological slides, these pink, or you can see these pink bundles, right? You can appreciate these are going to be collagen fibers, collagen collagen fibers, right? Right. So these will be your collagen fibers. And you can actually tell a difference between an active and inactive fibroblast by the, the staining of the intensity of staining of the nucleus. So if the fibroblast is active, it's going to have a chromatic nucleus that is going to be deeply stained, right? And you're also going to even it's going to show a deeply basophilic nucleus, right? As well as there will be a large number of rough endoplasmic reticulum to synthesize the collagen proteins, right? But if it is inactive, you can see that it is less bluish, which means that the nucleus has what? Hematochromatic, a heterochromatic nucleus. So this is going to be a vessel. This is a capillary, right? Capillary fibroblast, fibroblast. Yeah, this is a fibroblast. This is a fibroblast. So we also have adipose tissue. So adipose tissue, we won't talk about much about them because they are mainly found in the adipose tissue, but just have to take note of them. Um, they are divided into white and brown. And if it's white, it is going to have a segment in appearance and a large lipid droplet. You can see this one that will displace the nucleus to the periphery, resembling a segment ring appearance. You can see, right? And your adipose tissue is going to be highly vascularized. You see these capillaries, another capillary here, right? Because they take part in heat as well as energy, right? They reserve energy. So during fasting phase, you can have your triglycerides, right, being used to produce ATP and so forth. Now we go to macrophages. Macrophages, these are phagocytes that will be found in your connective tissue. They are not differentiated or formed or driven from the connective tissue, but they come from cells, precursor cells called monocytes. So you have your hematopoietic stem cells in the bone marrow that will form these monocytes. And these monocytes, they will escape into the blood, circulate around right around the body, and then what invaginate the connective tissue. Uh, then they differentiate into macrophages. So macrophages has two main functions. One, they act as antigen presenting cells because they are going to have uh, the MCH, the MHC2, right? That will be used to represent these what? These antigens, right? To T cells and D cells, is it? You're also going to have your plasma cells, and we said these are what? These are lymphocytes. And lymphocytes, are they transient or fixed? They're transient, right? So the main function of plasma cells, they are going to secrete antibodies, your immunoglobulin antibodies, and these antibodies, they are going to act to bind to antigens and present the antigens to macrophages, become phagocytosed via what we call the complement system, right? So the process is called opsonization, where an antibody presents itself uh, to the macrophage for phagocytosis to take place. So if you want to see how do you distinguish plasma cells, they have a clock face nucleus. You can see this one, clock face nucleus. You can also see this one, clock face. You can also see this one, it looks like a clock. The nucleus looks like a clock. You can see this one, clock face, right? Very important. Right here, you can see this is your plasma cell. So a plasma cell, remember, it's a mature lymphocyte. You see a clock face, this one, and then you can have these that are the hours, right, surrounding what your central point. Now let us go to mast cells. So mast cells are very important because they have the principal function to store secretory granules that will contain what you call histamine, heparin, and so forth. Right? So they are mediators for inflammation, which means they activate allergic reactions. Right? So their reactions, they are called the hypersensitivity reactions, right? Which can respond to certain characteristic of allergens, asthma, and anaphylactic shock. What is important is this: the mast cells, histologically, they are said to exhibit metachromasia. So metachromasia is that when stained with tolidine blue, the granules bind the dye and change its color to red. So they change the color of the dye that has been exposed to them. So if the blue color, you've exposed a blue color to the mast cells, what they change that color to red, so they give you a red picture when you are expecting a picture. So on your histological slides. Now let's go to extracellular matrix. So the extracellular matrix is divided into protein fibers, that will be collagen fiber, elastic fiber, and then you're going to have your ground substance and fluid as well. So let's start with the collagen fibers. So collagen fibers, these are formed from protein called collagen, which is a very strong, inelastic, flexible protein which has a great tensile strength. That's why the collagen fibers are used to form bones, aponeurosis, ligaments, tendons, because they are strong, right? They're also going to have fibers lasting, and they have the ability that if they are right, force remove their original shape. That is what called the recoil strength. We also have reticular fibers. So reticular fibers they are also collagenous fibers type 3, but they are specifically found um, between cells of tissues, right, and organs, right. So they form what called the stroma of organs, which is the supporting unit of the functional cells within that organ, right. So here this is an H and E and a trichrome uh, stain. So they can give a certain color depending on the what on the what on the stain, right. But we mainly focus on the H and E stain. So you can see these bundles, these are pinkish bundles, right. So these are all your collagen fibers, and you can see this is a nucleus. You can see the nucleus of a fibroblast is oval. So this is your fibroblast, right. You can appreciate here this is your fibroblast, right. And this is another fibroblast, right. And it's another another fibroblast. These pink, these are your all collagen fibers mixed in extracellular matrix. Right. The same is now. Let us go to reticular or reticular fiber. So reticular fibers, they surround delicate. They act as a delicate supporting framework, right, for highly cellular tissue. For example, you can find the reticular fibers surrounding your endocrine glands, lymph nodes, liver, bone marrow, spleen, even smooth muscles. You be having your reticular fibers there. And this is very important that they are composed of collagen type 3, right? Collagen type 3, right? And with a carbohydrate, they, they also have a carbohydrate unit, right? That can reduce silver to a silver ions to silver metal, right? So they are said to be agyrophilic, right? Agyrophilic because we use stains that have silver components to what to identify these reticular fibers. So they are said to be agyrophilic. Special stain, like I said, silver. You have silver compounds, right? That to impreg that to give uh, that are going to stain your your reticular fibers, right? So it's for you to visualize them, right? So they are said to be agyrophilic because they can be stained with silver compounds. So the reticular fibers, they are very thin, they are very thin, very thin. So you can see the comparison of a reticular fiber, which is collagen type 3 and collagen type 1. So collagen type 3, it is about 20, 30 to 40 nanometer diameter, right? And the type 1 about 200 nanometer diameter. Right, so network of elastin molecules can stretch and recoil like a rubber. So if force is put in this direction and in this direction, they become stretched like this. And if the force is removed, they recoil to their original shape. Now let's talk about the ground substance. So your ground substance is going to be made by proteins, right? Um, Substances, but the most abundant is uh, your your GAG, that is your glucosaminoglycans, right? And this one is gonna contain polysaccharides that include heparin sulfate, chondroitin sulfate, keratin sulfate, hyaluronic acid, and so forth, right? And they are very hydrophilic due to abundant negative charges. So you're going to have these ground substances. They are going to have a lot of water because they are very hydrophilic, very hydrophilic, very hydrophilic. You can also have proteoglycans, right? Core protein plus ground substance chains, right? Right. So these they bind cells and other proteins together within the extracellular matrix, right? You also have adhesive, multi-adhesive glycoproteins, smaller glycosylated proteins containing numerous binding sites to cells, and then they also take part in signaling molecules, right? So that is what is important. For example, laminin and fibronectin. Laminin, remember, it is found in the basal lamina, right? Together with collagen type 4. Right, so there's classification of your connective tissue. So your connective tissue is classified, right, into three, right? You have connective tissue proper that is divided into loose and dense. And then you're going to have specialized connective tissue that will include your adipose tissue, elastic tissue, hematopoietic, as well as your mucous tissue. And then you're going to have your supporting connective tissue, that is your cartilage and bone. So let's start with here we are going to focus on connective tissue proper. Connective tissue proper is divided into loose and dense. The loose connective tissue is also given a name as areolar connective tissue. It is very vascularized and delicate, right? And usually it supports the epithelia of major organs and veins and fills the space between muscle tissues. And it is noticed very resistant to stretch because remember it is a loose connective tissue, right? So what is important here on loose connective tissue is this: it is found in the GIT as the lamina propria. It is found in the respiratory tract as the lamina propria, right? So that is loose connective tissue, very important. So from loose, we can also have dense connective tissue. So now in dense connective tissue, it means that we have more, in loose connective tissue, you have more ground substance than fibers. But here in dense connective tissue, you're going to have more fibers than what? Than cell and less of ground substance, right? So you're going to have dense connective tissue divided into two: dense irregular. So irregular is gonna have fibers that are not arranged in one direction, but they are arranged in multiple directions, and they are able to resist multi-directional forces, e.g., the skin in the dermis, right? The dermis of the skin, some organ capsule, and fascia. So the fascia is dense, irregular connective tissue because it has to withstand abrasion from all direction. Also have a dense regular connective tissue. This one now it will form uh, the fibers. They will be arranged in a defined pattern, and they can form ligaments, tendons, aponeurosis, right, and resist uh, linear mechanical stresses. Also, you have adipose for fat storage, glucose regulation, and right. So, uh, reticular fibers, remember we said that they are type 3 collagen, right? And they are agyrophilic because they are stained with super compounds, right? They can be found as a stroma of highly cellular organs for the liver, for the lymph nodes, for the spleen, right? So this is a histological picture of your loose connective tissue. It's delicate, vascularized, flexible, facilitate transport of cells and minerals and materials, right? By secretion, absorption, and immunity. right? So you can see this is your this definitely have to be a GIT, because I can see this is your simple columnar epithelium in the GIT, and I can appreciate a brush border here. Brush border. You see a brush border here. So in a blue, that will be basement membrane that will separate your basal lamina to your connective tissue. Basal lamina to sorry, the basal lamina, it will be connected to the connective tissue below by the reticular lamina. Remember, right? So this is your lamina propria. It's going to have highly vascularized, because the blood, the nutrients in the blood, they have to be supplied to the exit. So you can see this is a blood vessel, this is a blood vessel. All of this is loose connective tissue, loose connective tissue, another blood vessel over here, and blood vessel. So you can clearly appreciate uh, that that loose connective tissue it indicates. Now let us go to mucous connective tissue. So mucous connective tissue, it is mainly formed of, it has collagen fibers, but these collagen fibers, they're going to be embedded into your mesenchymal cells, or being synthesized by mesenchymal cells, right? They haven't differentiated yet into fibroblasts, because you are talking about uh, this process taking place in what? In the uterus, right? So you can clearly see this space being the utera. Let's see. So this is a cross section of a spinal cord, and this is called mucus, mucus connecting connective tissue, right? So you can see the liver reticulin, right? These are all your hepatocytes, right? Hepatocytes here, hepatocytes here, and they're supported by these blue structures, right? Brown structures that are called reticular fibers made of collagen type 3. Adipocytes predominate in adipose tissue, right? You said this right. The adipocytes, they are mainly found in the adipose tissue. They are very active cells with many functions, right? But most of the function is that they are also, first of all, is that they secrete lactin, right, which is a hormone that suppresses appetite, right? They also store triglyceride, right, and and glucose metabolism, is it right? So you can, how do you see in adipose tissue? You can see this large cell and a peripheral nucleus, large cell, peripheral nucleus. So they have a segment ring appearance, segment ring appearance, segment ring appearance, right? Right. So it's divided into two, right? It's you have a white adipose tissue. So white adipose tissue is the one that is a large lipid droplet and a nucleus peripherally displaced, right? That is your white. And then as for your white is abundant in adult, while your brown adipose tissue is abundant in newborns, right? Because the brown adipose tissue is called multilocular, while the white is called unilocular. So the multilocular is going to have a lot of uh, this. You can see this is your white, and this becomes your brown. Your brown is going to have a lot of lipid droplets, right? And the nucleus is not peripherally displaced, right? and they are responsible for generating um, uh, heat, what you call non-shivering heat, right? Non-shivering heat, right? Remember, your newborns, they are not able to produce kinetic energy that it will convert. Uh, they are not able to move, so they cannot convert kinetic energy to heat. So we have these multilocular brown tissue that will be secreting, that will be, they will have a protein called thermogenin, which will be found on the membrane of your mitochondria, and they are responsible for uncoupling reaction, right? Uncoupling reactions, right? Sort of like it is short circuit the electron transport chain, thereby instead of producing ATP, it will produce heat, right? So this will be your multilocular, this is your unilocular. Is it? They will come from the mesenchyme, and the mesenchyme is going to differentiate either into fibroblasts or lipoblasts, right? And the lipoblast is going to form multilocular. They'll start to form multilocular adipose in newborns. Then as you grow, right, and you are now able to move, you now have your unilocular here. So now let us go to dense connective tissue. So dense connective tissue is divided into regular and irregular. So this is a regular connective tissue. How do you see? You see the fibers, they have a definite pattern. You can see they are arranged going in this direction. That's it. So this is your regular. And you can see the spindle-shaped fibroblasts. And with the what? With the ovals shaped nucleus. You can see, 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 right? So the location of the dense regular connective tissue, it forms the tendons and aponeurosis, right? Because it facilitates displacement of force, right, in one direction, distribution of force in one direction. So let's say you want to pull your muscle towards this direction, right? So as the muscle contracts, this is your bicep to pull this direction. So you want the force to be distributed along this direction. So you have these uh, fibers arranged in that way, right? So examples, these are your tendons, your aponeurosis, your ligaments, right? So again, so this is your regular dense connective tissue, your collagen moving in this direction, in the same direction, you can see, very important. Then we go to dense irregular. So dense irregular, from the word irregular, you are going to have your your connective tissue or fibers, right? Your collagen fibers. They will not, they are not going to be arranged in an orderly manner, right? They are arranged in all directions. This going in this direction, this go another going in this direction, another going in this direction, right? So their function is that they provide strength, right? And they provide strength as well as they resist force in all directions. So they are mainly found in the dermis of the skin, in the dermis of the skin, in the capsule of organs, right? That would be your dense irregular, even in the periosteum and periosteum of bones, as well as your perichondria of bones, of cartilage. I mean, okay. This is another histology slide showing your dense irregular fibers. You can see these are dense irregular fibers. Some fibers are longitudinal, some fibers are vertical, some fibers are horizontal, and so forth. You can appreciate adipose tissue here. What type of adipose tissue are these? These are your what? Your white adipose tissue, right? You see the nucleus is peripherally placed, right? So this is your skin, is it? This is your skin, so you can see your loose connective tissue right here. that is between your sweat glands, is it? So you can also have elastic tissue. So elastic tissue is going to have elastin fibers, elastic fibers, right? These are your elastic fibers, right? And they are also formed from your what? Your fibroblasts, right? So between they can be found between the vertebrae, right? Forming your ligament. For example, the ligamentum flavum, right? That will be your ligament. That will be joining your lamina of your vertebrae, is it? They can also be found in the penis. They can also be found in um, the aorta, in the tunica media of the aorta. They can also be found in your outer ear or auricle of the ear and so forth. Right. So clinical correlates, right? Connective tissue, like we said, it forms scar tissue during wound healing. The scar tissue will be made it consists of collagen type 2 and type 1, type 2 and type 3, right? Then excessive production of fibers leads to fibrosis, right? And fibrosis takes place mainly, you have what you call liver fibrosis, right? Where you have overproduction of fibers, and liver fibrosis can lead to pulmonary hypertension, that can lead to what you call corpus medis and so forth. You can have edema, right, which is excessive production of fluid in your connective tissue, that can lead to swelling, right? And remember, we said we have mast cells in the connective tissue, so you can have immediate hypersensitivity reaction. That are your allergic reactions immediated by mast cells, e.g., in asthma, in hay fever. You also have inflammatory reactions, right? That can be mediated by white blood cells, lymphocytes, right? Macrophages, right? Your, your the neutrophils, basophils, eosinophils, right? That will establish these inflammatory reactions. So this is a table to classify um, disorders of collagen fibers. So you just have to take note of it, and yeah, that's everything that we have for today. So thank you so much for joining me into this lecture. See you next time.